Okay, multiplying radicals. I think we know what a radical is, and I think we know how to multiply. So what we're going to do is we're going to try to multiply radicals. So remembering the product property of roots will just get us started in the right area. That we want to remember that, I guess let's talk about the radical again. That remember I have an n is going to be my index, and a would be my base. So I could have, in this case, if I have like indices, that would be the same thing as the nth root of a times the nth root of b would be the same thing as the nth root of ab. So just understanding here that product property of these roots, and I mean, if I were to try to, and then, well, let's just say conversely, the nth root of a times b is going to be equal to the nth root of a times the nth root of b. Again, just sort of playing with the power of the root there. So if I use the example here, and we'll say that the cube root of 16, well, we're looking over here. The cube root of 16 could also be, remember, if I wanted to make this easy on myself, my perfect cubes are 1, 8, and 27 to get started. So I know that the cubed root of 8 times the cubed root of 2 is the same thing as the cubed root of 16. Well, I know that the cubed root of 8 is actually 2. There is no cubed root of 2, so then that would just be times the cubed root of 2. And that would be the simplified version of that root. So just remembering these product properties, and we do want to say, hey, what are we trying to do? We're trying to perform the multiplication of radical expressions. And how can you multiply radical expressions? Moving forward with our examples. Okay, so looking here how to multiply some radicals, we have the example here where I have the cube root of d times the cube root of d times the cube root of d. And I could look at that and say, well, that would be the cubed root of d times d times d. It is also the same thing as the cubed root of d cubed. And then therefore that is going to be d. If I were to look at it from the rational exponent, this would be d to the 1/3 times d to the 1/3 times d to the 1/3. Well, that is d to the 1/3 plus 1/3 plus 1/3, and then that is just d to the first power. So there's different ways to look at this and try to come up with a solution. I'm just trying to present those different ways to you for you to decide what is best for you. Again, this next example, I have the fourth root of 7. 7 times 7 times 7 times 7. Well, that's the same thing. I'm looking for one number times itself 4 times. Well, the 7 is multiplied times itself 4 times, so the fourth root of 7 times 7 times 7 times 7 is 7. So that's just reorganizing that and reordering it. And this next example is going to be the fifth root of 4x squared times the fifth root of 4x squared. And that is going to simply be the fifth root of 4 times x squared times 4 times x squared, and that is going to be the fifth root of 16x to the fourth. And there is no fifth root in there for me to be able to pull out and make that any more simplified, because 16 is actually 2 to the fourth power, so there's not 5 2's, and then x to the fourth, of course, is to the fourth power, not fifth power. So this is about as simple as it's going to get right there. Now, as we look at multiplying polynomials in these radicals, or, that's sort of what I'm referring to, like a monomial and a binomial, because we've done monomial and monomial. Remember that when we have a times x plus 1, remember that this a is going to be distributed to both of those terms. So that actually is going to be ax plus a times 1, which is ax plus a. So we're going to use that same guiding principle as we multiply radicals. So in my example, I'm going to have the cubed root of 4 times 1 plus the cubed root of 2. Okay, so remembering that, again, we have to multiply. This is the distributive property. We have to distribute that to both things inside the radical, inside the parentheses. So I end up with the cubed root of 4 times 1 plus the cubed root of 4, not plus, but times the cubed root of 2. And then that is going to equal just the cubed root of 4 plus the cubed root of 4 times 2, which is also 8. And then I know 3 times the cubed root of 4 plus the cubed root of 8 is 2. And I'll be honest with you, you should probably know the first 5 cube roots, and I've talked about that in previous videos. But so here is the equivalent expression when I'm using the distributive property. Now we'll also talk about multiplying with the FOIL method, or multiplying two binomials together. Okay, so multiplying a binomial times a binomial, I have x square root of 7 minus 3 square root of 8 times x square root of 7 minus 3 square root of 8. So it looks like that might have been, squared. So remember, when we do this, we're going to use the FOIL or whatever method that you have chosen to do binomial multiplication. And so the first term has to be multiplied by the other two terms, and then the second term has to be multiplied by the other two terms. So again, everything is getting multiplied here. So starting off with the first expression, I have x square root of 7 times x square root of 7 plus the x square root of 7 again times a negative 3 square root of 8. Continuing on, I have the negative 3 square root of 8 times x square root of 7 minus 3 square root of 8 times a negative 3 square root of 8. So now I have 4 terms, right? When I multiplied this times 2 terms, and when I multiplied this times 2 terms, I am looking at having a possible 4 terms now. And as I do this, let me just go ahead and say that I have x squared times the square root of 49. I have, negative, right? That's over here, negative 3x square root of 56. Then I have negative or minus 3x square root of 56, and then plus, right? Negative and a negative is going to give me a plus 9 square root of 64. Well, I can tell you that this one's easy. This is going to be 9 times 8, which is going to be 72. The first term is going to be x times 7, or 7x. Now it will get more challenging. So I have minus 3x, and the radical, right, of 56 is 4 times something, I think. 4 times 14, maybe, will give me 56. So then I know that the square root, I have 3x times the square root of 4 times the square root of 14. So that is going to be 3x times 2 times the square root of 14. And then the next one should be the same, right? Because these two expressions, or those two terms, are the same. So I get a negative, and I'm going to go ahead and just do some combining right now. That is going to be 6x square root of 14. And I can go ahead and fix this one up. 6x square root of 14. Okay, when I do some combining now, it looks like I'm going to have 7x minus 12x square root of 14 plus 72. And hopefully now that I look at it, everybody has been screaming that I did something wrong. And I forgot that too, I forgot that too, and I forgot that too. So we have 7x squared minus 12x square root of 14 plus 72. So there you go, that is multiplying two binomials together. Okay, when we are trying to multiply radicals that have different indices, there's a couple of steps that we're going to follow, but an example here is going to be, I'm going to put one more, I just can't do that. It's just entirely too many colors. So an example here is we're going to be dealing with the square root of xy times the cubed root of x squared. And so since they have different indices, we can't do anything with them right now, but what we can do is just follow these steps and rewriting using a rational exponent. So like I did in the very beginning of this video, I have x to the, or I guess xy to the 1/2, because this is the power of 1 and the index is 2, times x squared to the 1/3. No. To the 2/3, right? No. Actually, I did write it right, but let me just go ahead and just call it to the 2/3. And then now when I can go ahead and I can write them now with a common denominator. So I would have xy to the 1/2. Just going to write it a little bit bigger so we can see it. And then x to the 2/3. So remember, when we are adding fractions, right, we want our common denominator. The common denominator between my 2 and 3 here is going to be 6. So this would be xy to the 6th denominator, so I'd have to multiply everything with times 3, so that'd be 3 over 6. And then x to the 4 over 6. And now I have a common denominator, so I can go ahead and rewrite this as the 6th root of xy to the 3rd, or if we think about that, that is the same thing as x to the 3rd, y to the 3rd, times the x to the 4th. And so I'm looking at the 6th root of x to the 7, y to the 3rd. So that is going to be, well, we're going to be able to bring an x out and leave an x in. Because I had 7, I was able to use 6 of them to multiply together for that 6th root, leaving one behind, and then of course y to the 3rd, because I don't have 6 of those to develop that root. So there we go. There is going to be my simplified radical. Given that I had two different indices, I had to first write into a rational exponent, then I rewrote with a rational exponent, rewrote with a common denominator, and then I wrote as one root, and then I was able to simplify as possible. And that is working with different radicals, multiplying different radicals, and just remembering that when we're multiplying radicals, we wanted to perform those multiplication of radical expressions using, the basics of the product property of the roots. And, we should be able to say that we can apply the distributive property and we can apply the FOIL method and to work with like and unlike indices. So practice, and just pay attention to what you're doing. And in many ways, little things are going to inhibit you, fractions and attention to detail. So we just continue on and we persevere.